Our next presenter is Blaine McCarthy, and the only additional information I have is that it's a fourth-year student pursuing a PhD in chemistry, and that Blaine sounds like chain. So, with that, her title for today is Growing Green Plastics Using the Sun, or her.
How many plastics have you used today? Did you think about the toothbrush that you used when you woke up? The soles of your shoes? What about the plastic bottle or coffee cup that you might be drinking out of right now? Plastics are undoubtedly an important part of our everyday lives, but the way that we make and dispose of these materials has detrimental effects on the environment. This is the dichotomy of plastics. While we try to shift away from single-use plastics, many other plastic materials are responsible for sustaining our global population through the cost-effective production and distribution of food, medical devices, electronics, and more. In fact, in the United States, we produce about 300 pounds of plastic per person each year. Due to the importance of plastics, it is imperative that we question the way that we make these materials from an economic and environmental perspective. Industrially, plastics are typically made using heat, which is energy intensive. So finding ways to drive these processes at room temperature is desirable. Doing this would be like baking bread without having to put it in the oven. Reducing these energy inputs could decrease the 4% of global energy that we currently use to make plastics. Metals are also commonly used to make plastics. However, these can be incorporated into the final product, so using these methods to make implants and other biomedical devices is undesirable. Motivated to address these drawbacks of the current plastic production processes, we wondered whether we could remove metals from these systems and use sunlight as a renewable energy source instead of heat to make plastics. The aim of my doctoral research in chemistry has been to develop OATRP, a metal-free and light-driven way to make the plastics that you use every day. The way that our technology works is analogous to the way that plants can harness solar energy to perform the chemical reactions that are essential for their survival. We have already identified several OATRP systems which can successfully make plastics using sunlight or the commercially available LEDs that you could buy at Home Depot. Because light is a necessary component of this system, we can start and stop the process with the flick of a light switch. In addition, we can apply this method to make degradable plastics, and this could help us avoid issues with plastics buildup in the environment. OATRP can resolve the dichotomy of plastics. And through this work, I envision that we can have a future where we sustainably produce the plastic materials that enrich our everyday lives through growing green plastics using the sun. Thank you.